So, good afternoon, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the Mentor Hampel Kliman. And of course, I bring you yet with another video session where I'm going to be simplifying logarithms and taking them to their simplest form. Of course, if you have challenges in physics, mathematics, chemistry, biology, make sure that you register for personal tuitions at HC Academy. Just inbox me on this WhatsApp number. It's a +26077 66 40 46, and I'll be able to reply to you. We have this interesting question which is saying we solve each of the following equations. Of course, I'm going to solve the first three in each session so that I leave you the rest with the same concepts. So the first thing that we do, these are exponential equations. The first equation that we have is saying we have been given this is a 2 to the power 2x plus 3. Then we have a 2 to the power 2x here minus a 4. Then we have been told that this is equivalent to a 0. So now, there is a way in which you manipulate this in order to make it easy for yourself. How do you manipulate? Notice that 2x, or let me just say 2 to the power 2x can also be written as 2, then x, right? Then everything to the power 2, okay? So that if you say 2 multiplied by x, it's going to be 2 whole number, then 2x, right? So this part here can also be written as 2x, then to the power 2, okay? Plus 3, then 2x, like that, then minus 4, then this is going to equal 0. Now, you have this part here, so you can say let y equal to 2 to the power 2x, okay? Or let me just say y equal to 2 to the power x. So that implies that I'm going to put y in here, plus 3, then y also in here, minus 4 equal to 0. Then this is just the same as y to the power 2 plus 3y minus 4 equal to 0. Then from here, I'm going to find the product and the sum. So the sum is simply positive 3. The product is simply negative 4. So what are the factors? The numbers that if we multiply, if we add them, they will give us 3, positive 3. If we multiply them, they will give us negative 4. Of course, it's going to be a negative 1. Okay, negative 1 and positive 4. Okay, so negative 1 plus 4 is giving us positive 3. That's the sum. And then negative 1 multiplied by 4 is giving us negative 4, which is the product. So that means that we're going to have y to the power 2 minus y plus 4y minus 4 equal to 0. Y is going to be factored out. Then we're going to have y minus 1 plus 4, then y minus 1. So that implies we're going to have y is equal to 4, and at the same time y is going to equal to 1, like that. Okay? These are the certain solution. So this is equal to 0, this is equal to, sorry, that is supposed to equal 0 also. 0. Let me just wrap that part to make everything look nice. So this is supposed to be like this. So you're going to have your y there. So this is going to be y plus 4 equals 0, and also y minus 1 equals 0. So you're going to have y is equal to negative 4, and the y is equal to 1. So now you need to take the, you need to ask yourself, you go to, here you already had said that your y is equal to 2 to the power x. So you have y is equal to 2 to the power x. Then here you can put your negative 4 equal to 2 to the power x. Okay? But you know that this particular part won't give you a set value. okay, it won't give you any set value. Okay, so you forget this part. Don't give you any set value, okay, because it's a negative 4 there. But this part here, you're going to have 1 is equal to 2 to the power x, right? You put the set value of y there. Now, you already know that this can be manipulated. We can make the 2 the same by saying 2 to the power x is equal to 2 to the power 0. Why 2 to the power 0? Because I'm imagining that 2 to the any number raised to the power 0 is 1. Okay? Then this cancelled, your x is going to equal 0. So your y is going to equal 1 and your x is going to equal 0. Okay, that's how you solve this question. Let me try the second question. We see if it's going to work by using the same concept. You can use the same concept for everything. It's going to give you the answer. The second question is saying we've got a 3, then 2x plus 1 minus 26. Then inside we've got 3 to the power x equal to 9. The same concept. Notice that we've got a 3 to the power 2x here plus 1. This can also be written as 3 to the power x, like that. Then everything raised to the power 2, right? That is just one and the same. But remember that for them to add, it means you are multiplying two things having the same base, right? Okay, so you are multiplying 3. Okay, so whenever you're multiplying two things of the same base, you add the powers. So whenever this here that I've written here is just the same as 3 to the power 2x plus 1. Why? Because this is raised to the power 1. And since you're multiplying these two, they are the same bases, they will add the powers. Please make sure you take note of that concept. So this can also be written as 3 to the power x, then everything raised to the power 2, and then multiplied by a 3 here, raised to the power 1, then minus 26, then 3 to the power x, then to the power 3 to the power x, then 9 here. We can use the same concept how we say we can let our y equal to 3 to the power x. So it implies here I can put y to the power 2, okay, then multiplied by 3, then minus 26, then I can put my y here, then equal to 9. So this is going to be 3y to the power 2 minus 26y, then equal to 9. So this can also be written as 3y to the power 26 minus 26y minus 9 equal to 0. So this already, from the look of things, I'm able to tell that I won't be able to find any factors. It won't be easy for me to find the factors. So what do? I'll use the quadratic formula, where I'll say this is going to be negative b plus or minus the root of b to the power 2 minus 4ax, like that, over 2a. That's the concept I shall use, because this has got no factors. Don't give me factors. So this is going to be, let me see what I'm going to get here. So my a, of course, is giving me 3. My b is giving me negative 26. My c is giving me negative 9. So this is going to be y is equal to, what is the b? Okay, so because there's a negative here, so this is going to be a positive because there's a negative here, and b is negative, so this will be a positive 26, like that. Then this is going to be a plus or minus. Then of course I'm going to have this is going to be negative 26 to the power 2 minus 4. What is a? My a is 3. What is c? My c is negative 9. Then all over by 2, then a is 3, like that. So I'm going to have y is equal to 26 plus or minus the root of, okay, so this is going to be 26 to the power 2. 26 to the power 2. What am I going to get? Let me see if I'm going to get something. So of course it's giving me 676 minus, then of course I'm going to, sorry, this is going to be a plus because there's a negative here. So this is going to be plus. Then I will make everything. So this is going to be 4 multiplied by 3. multiplied by 9. Okay, why a positive 9? Because it's going to, they'll add here. Okay, we already know what is happening here. Okay, so of course I'm going to have a 108 there over uh, 6. So 108 plus 676, 676, and I'm going to get a y is equal to 26 plus or minus square root of 784 over 6. Then you find the square root of 784 is giving me 28. So we are going to have y is equal to 26 plus or minus, then here you're getting 28 over 6. Now I want to show you how to solve square roots in case maybe you do not have a calculator. You want to find the square root of 28 in case you do not have a calculator. So square root of 28 without using a calculator, how do you solve the square root of a number without using a calculator? So you bring down the square root, you say square root of 27, then you say plus 1 over 2 multiplied by 5. Every time you reduce the square root, you do what I've done there. So even this, so if you bring it to 26, you say 1 over 10 plus another 1 over 10. Again, if I reduce it to 25, I'm going to add 1 over 10 plus 1 over 10 plus another 1 over 10, like that. So this is going to give me 5 because it's a common root, 5. Then plus 1 divided by 10 is 0.1 plus 0.1 plus 0.1, like that. From there, what else can I do? This is going to be 5 plus 0.1 plus 0.1 plus 0.1 is going to give me 0.3. And I'm going to get 5.3. Okay, let me check if it's true on the calculator. Square root of 28 is giving me 5.29. On the calculator, it's giving me 5.29. Okay, so from there, this is just the same as y is equal to 26 plus or minus 5.3 over 6. Okay, so we have 26, y is equal to 26 plus or minus, I'm getting 5.3. Let me see, this is 5.3. So 5.3 over 6. Okay, this is interesting. So what is 26 plus 5.3? So you can say 26 here, 0.0, then we have 5.3. So this is going to give me something like 2, sorry. This is going to give me 3 point. This is giving me 11. Carry 1, this is going to give me 31. Okay, so this is going to be y is equal to 31.3 over 6. Okay, 31.3 over 6. Like that. Okay, over 6. Let me check what I am going to get. Okay, so okay, so 26 plus 5.3, 5.3, 31.3 divided by 6. I'm getting my y is equal to 5.2. At the same time, I'm getting a y is equal to, so this is going to be 26 minus 5.3. Okay, like that. Let me check. All right. I see I've made a mistake somewhere. Made a mistake somewhere. Okay. I've made a mistake somewhere. Let me see where the mistake is. All right. Anyway, at least I've showed you how to find the root of a square root number without using calculator, but I don't think that was necessary. So what we just needed is y is equal to 26 plus or minus. What did we get? 26 power 2. That was a 676. This is going to give us a plus. Then 4, open bracket, 3. And then here we're having a 9. So it's going to be 108 over 6. 26 plus or minus. So plus 676. Yes, then we find the square root of this number is 28. So it was giving us a solid 28. Then we can say plus 26 divided by 6. So our y is giving us a 9 here. How about if we subtract 26 minus 28? It's giving us 26 minus 28. It's giving us a negative 2 over 6, which is giving us a negative 1 over 3. So now going back to our question. The question was saying, remember we had already made this theory here. Let me just use a different color. Okay, so if I use a different color, I already have y. This part won't work because it's a negative, so you use this part. So you can put 9 where there is a y. So this is just the same as 3 to the power x is equal to 3 to the power 2. So that is going to give you a 2. Okay, that's how you find that particular question. That's how you find that particular question. It's quite very simple, guys. All you have to do is to just understand. So even the third one, you can do the same. This question, you can do the same. You can manipulate it. Okay, I won't go far. So this is like 4 to, okay, this is like 4 to the power x is equal to, okay, this is 6 what? 2x. So inside they've given you a 2 power to the x here, then they are saying this is an addition of 16 plus 16. So how do you manipulate? You can just say this is the same as 2 to the power 2x, like that, equal to 6 to the power 2 to the power x there plus 16. Then you can simplify this. How? You can say this is just the same as 2 to the power x, then to the power 2 like that, equal to 6, then 2 to the power x plus 16. Okay, so from here you can just say you let y is equal to 2 to the power x. Henceforth, you can put your y in here. Then this is going to be your y, then 16. So this is going to be y to the power 2 minus 6y. This is going to be minus 16 equal to 0. So we can use the same concept. We can say our a is 1, our b is negative 6, and our c is negative 16. So this is going to be y is equal to, because b is positive, is negative. Remember the formula is negative b plus or minus the root of b to the power 2 minus 4ac. 4ac, sorry, it's supposed to be 4ac over 2a. So this is going to be y is equal to what is, so our b is negative, so it's going to be positive 6 plus or minus square root of what is b to the power 2. Okay, so this is negative 6 power 2 minus 4. What is a? It's 1. What is c? It's negative 16. Then this will be a 2 because a is 1. Then this is going to be y is equal to 6 plus or minus what is everything inside. So this is going to be, that is going to be a positive, so it's going to be a 4. 4 multiplied by 16 is 64. 64 plus c, 6 to the power 2 is 36. So 100. It's giving me 100 over 2. So this is y equal to 6 plus or minus 10 over 2. So what is 6 plus 10? 6 plus 10 is giving me 16 over 2. The other one won't even work. 6 minus that is giving me negative 4 over 2. So my answers are therefore going to be y is equal to 8 and y is equal to negative 2. This solution won't work because it's a negative. So already y there we have, so we're going to have 8 is equal to 2 to the power x. So 2 to the power x is going to equal to 2 to the power 3. So that cancelled. X is going to equal to 3. Well, that's just how you solve these particular questions. They're very simple. You just exponential functions, exponential equations are very simple. Just use the substitution method. You will find the answer. We get to these questions. The first one is saying we solve each of the following equations. So the first one is saying we solve 3x is equal to 5. So for these questions, you need to introduce the natural log, and the natural log is going to make everything easy. So you can say this is just the same as you introduce ln. So this is going to be ln 3 to the power 3x equal to ln 5. So this can go this side so that it becomes x ln 3 equal to ln 5. So over ln 3 over ln 3. You cancel that, you are going to get, let me try to, what is the natural log? Natural log of 3 or 5 divided by the natural log of 3. And I'm getting a 1.5 if I round it off. We do the same thing to the second one. These are very simple, of course. So this is going to be, it's a 2, then x minus 1 equal to 7. I'm going to introduce the same concept, ln, then x minus 1, okay, in brackets, equal to ln 7. From here, what can I do? How can I simplify that? Well, it's very simple, guys. It's very simple. To simplify that, I am going to say this guy can go this side so that we're going to have x minus 1, then ln 2 equal to ln 7, then over ln 2 over ln 2. So we're going to have x is equal to ln 7 over ln 2 plus 1. So let's do our calculations. What is ln 7? Ln 7 divided by ln 2. So this is going to give you like a 2.8. So this is going to be x is equal to 2.8 plus 1. Our x is going to be 3.8. That becomes our final answer. We can do the same thing to the rest of the questions. You can do the same thing. Introduce ln this side, ln this side. You solve. Introduce ln, introduce ln, introduce ln. Your answer is going to come out. Okay, so those are very simple actually. We won't waste much time there. We have question 15 is saying we prove that log base 2 of 7 can also be written as log 3 of 7 over log 3 of 2. This is change of base formula, guys. They are simply telling you take it to the log base 3. So if I take this guy to the log base 3, okay, it's going to be log base 3 of 7 over the same desired base then of this guy here. Okay, so if you change that, then that becomes this, that is just the same as log 2 of 7. Just one and the same thing if you change it to the base 3. So here they just want to show you, they just want to show them, you show them that if you change it to the base 3, it's going to be like that. The second one, you have log y, then you have y, then you have x log base y, then k. They are saying show them that this is equal to x to the power k. So remember the properties of logs that I already taught. Log a of a is equal to 1. So this part here is equal to 1. So that is going to be 1 multiplied by x is going to be x. Then log y, then y to the power k. This part here is the same as this part here, and it is still a 1. 1 multiplied by k, it's going to be y, it's going to be k. So 1 multiplied by k, it's going to be x to the power k, and that is equal to x to the power k. Then this side they are saying we prove log e is equal to 1 over ln 10. So of course we know that this is just the same as log base 10 of e. This is just the same as, so the way it is, the way this is, this can also be written as, if you introduce the natural log, this is just the same as natural log of this part. Please understand that there is this property that I want you to know. Log of log base b of a, if you introduce the natural log, it's just the same as log a over, sorry, it's just the same as natural log or ln of a over ln of b. Please understand that. That's the same concept we are going to use here. So log base 10, remember they didn't put base 10 there. If they don't put the base, you assume it is 10. So this is the same as ln e of e over the natural log of 10. But we know that the natural log of e is the same as 1. So this is just the same as ln, sorry. And already you are able to see the answer. So this is just the same as log base 10 of e is the same as, what is ln e? Ln e is 1 over ln e of 10. Then it means you have showed for that particular part. So it's all about knowing log bases, log properties. Let me solve you the last one, which happens to be 4. You solve, I want you to solve this one. It's actually the simplest. That's the simplest of all. Please make sure you solve that one. It's a potential question for any test. This one is, they're saying this is log 4 of 3. We show them that it is actually the same as log 2. Now, notice this. This is the same as, if you have log 4 of 3, remember what I taught in the previous lessons? You introduce the x, then you say 4 to the power x is equal to 4 to the power x is equal to 3. like that. Okay, let me see if it's going to make sense for me. Okay, let me see if it's going to make sense for me. So okay, so this okay, I see. Let me show you something, guys. They are saying we prove that it is log 2 of 3, right? So first of all, we change this part into base 2. So to change that into base 2 is going to be log 2 of 3 over log 2 of this guy here. Okay? Okay. Then that can also be written as, remember this part here is same as log 2 of 4. You equate this to x, then this power this. So it will be 2 to the power x is equal to 4. Then that becomes 2 to the power x equal to 2 to the power 2. That and that cancelled. We are going to have x equal to 2. So this is just the same as log 2 of x over 2, which is just the same as 1 over 2 log 2 of 3. Guys, remember log properties. This 1 over 2 can come this side so that it becomes log base 2 of 3 to the power 1 over 2, which can also be written as log base 2. 3 to the power 1 over 2 is the same as the square root of 3. You've proved, so make sure you do this one for me. Okay. We have this question, we solve the simultaneous equations. So this one is saying we have 2 log y is equal to log 2 plus log x. And then the other equation given is 2 to the power x is equal to 4. So now guys, look at this. Look at what I'm going to do here. This part here can be solved easily. So this is just the same as 2 to the power x is equal to 2 to the power 2. Then x is going to equal 2. So therefore, you can say 2 log y is equal to log 2 plus log, where there is x, I can put 2. This is just the same as log y, the guy can come this side. And this becomes, now, remember what I taught in the previous lessons, properties. Log of a plus log of a is the same as log a multiplied by a. Remember, addition is multiplication. So this is just the same as log 2 multiplied by 2. Why am I putting x there? Sorry. So this is going to be y is equal to 2 or negative 2. Now, when we reach here, what can we do? What more are we able to do? We have found y. Okay, so we know that log of a negative number doesn't exist. So the only real solution is the positive part of y. So our answers are going to be x is equal to 2 and y is equal to 2. Anyway, this one was simple. Let me try the second one. I see if I can make it simple also, guys. If I can make it simple. That implies you do the same thing to the last one also. We have log x plus y equal to 0. The other equation is 2 log x is equal to log base 10 of y plus 1. Remember guys, this if the base is not short, it's base 10. So this is log base 10 of x plus 1 y equal to 0, and this is just the same as 10 to the power, so you can bring this guy, becomes the power, then you say x plus y. So this becomes 1 because 10 to the power 0 is 1. Then you have x plus y. Name this one as equation 1. Then this part you are going to have the 2 can come this side, so it's going to become log x to the power 2 equal to this same as log 10 y plus 1. This guy and this guy can cancel, so we're going to have x to the power 2 equal to y plus 1. Okay, so we are going to have y minus 1 is equal to x. Okay, so therefore we are going to, let me solve for x first. One minus x is equal to y. So x to the power 2 is equal to what there is y. I can put my equation, which is here. 1 minus x plus 1. I don't want to start expanding things, so this will be plus x. Then this is going to be equal to 1 plus 1. Let me see if I can find the solutions. The product is -2. The sum is 1. What are the factors? Let's see if any. Two numbers, if I multiply them again, okay, so it's going to give me a 2 and -1. Because if I multiply 2 by -1 to give me -2, then if I add 2 plus -1 to give me +1. So this can also be written as x to the power 2 minus x plus 2x minus 2 equal to 0. So this is going to be x factored out, then x minus 1 plus 2, then x minus 1 equal to 0. So our x is going to be x plus 2 equal to 0, x minus 1 equal to 0. So we're going to have x is equal to -2, which can give us a real solution because these are logs. Then x is going to equal to 1. So our only solution here is x is equal to 1. Then we can say 1 minus, well, there is x, I can put my 1. This becomes y, so this is going to be y is equal to 0. And that is how you solve simultaneous equations. If you are interested, ensure that you solve this one for me and you inbox me on the same number. You send me my solutions. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Consider also registering for personal tuitions at Ampere Kleeman Online Academy, HC Academy, and of course you are going to enjoy the best of the Ampere Kleeman sessions every day at exactly around 22 p.m. Thank you so much.